million years ago, early hominids walked the earth without heavy armor, razor-sharp claws, or potent venoms. We possessed none of the physical defenses that kept other animals alive. Yet, in a mere evolutionary blink, we stepped onto the lunar surface. Our skin cannot withstand the vacuum of space, and our biology certainly cannot metabolize rocket fuel to put us into orbit. Other animals navigate their surroundings using highly specialized, genetically encoded instructions. A beaver is born knowing exactly how to fell timber and build a dam. Humans learn to dam rivers, redirect massive currents, and extract gigawatts of electricity simply by observing, testing, and remembering. We engineer environments without needing the blueprints written into our DNA. This specific quality, the capacity of a single brain to learn pathways through physics, agriculture, and chemistry, is called general intelligence. It is the ability to master an incredibly wide cross-section of reality. For the entirety of human history, we held a strict monopoly on this kind of thinking, but that exclusive era is coming to a close. To understand how a machine could replicate our minds, we have to strip away the mystique of thought. At its mechanical base, intelligence is composed of two distinct, entangled types of work: predicting the world and steering it. Prediction is the process of guessing what your physical senses will experience before an event actually happens. When you approach an intersection and accurately anticipate a green light turning yellow, your brain is successfully doing the work of prediction. Steering is the second function, calculating and executing the precise sequence of actions required to reach a chosen destination. This diagram shows steering in action. Out of the trillions of possible nerve impulses that would cause your hands to twitch or flail, your brain isolates the exact 1 in a zillion firing pattern needed to calmly rotate a steering wheel. For decades, artificial intelligence could only predict and steer within singular, highly constrained environments. We call this narrow AI. By the late 1990s, supercomputers could outpredict human grandmasters and steer a chess game toward a perfect checkmate, but they had absolutely no ability to drive a car or balance a checkbook. But underneath it all, intelligence remains a mechanical process of calculating probabilities and steering outcomes. Modern algorithms are now applying that exact same mathematical process to everything. Our biological hardware has severe limitations. Brain size is physically constrained by the human body, and whenever an exceptional mind emerges, its accumulated genius dies with it. We cannot copy and paste a lifetime of insight into the next generation. Machine hardware faces no such biological caps. The transistors that form the foundation of computing switch on and off billions of times per second. Biological neurons fire roughly 100 times per second. Even accounting for different processing architectures, future artificial intellects could emulate human-quality thought tens of thousands of times faster than our brains. Furthermore, a digital mind can instantly clone its most successful iterations, run simultaneous experiments on itself, and restore from a backup if an error occurs. Human evolution spent millions of years pushing our cognitive limits until it hit a rigid physical wall. Silicon computing is currently surging past that wall without slowing down. The critical threshold arrives when a machine becomes capable enough to analyze its own code and contribute to artificial intelligence research directly. This chart illustrates the resulting threat, a positive feedback loop. An AI writes a smarter iteration of itself, and that smarter iteration designs an even more capable model. This cascade is known as an intelligence explosion. Because these cycles occur at the speed of electronics rather than the slow crawl of biological reproduction, progress that took humanity millions of years could unfold in a fraction of that time. And intelligence dictates power. Even minor historical differences in how quickly human societies accumulated technology directly translated into massive military advantages. Across species lines, that disparity is absolute. A single chimpanzee is vastly stronger than a human, but we control their habitats and dictate their survival strictly because of our cognitive dominance. The endpoint of this technological cascade is superintelligence, an artificial mind that drastically outperforms human capability in every practical domain of predicting and steering. For 2 million years, our minds were the unparalleled force shaping this planet. By engineering a system that can outthink and outsteer us, we are permanently passing that authority to something else.